there was a few people that got a little tied up on those questions. So the task manager, if you pull it up, is probably the easiest way to figure out what it does. Let me make sure I'm sharing that screen. There we go. So, somebody who's got a lot of noise in the mic.
Oh, yes, Spider-Man?
Sorry. So much noise. There we go. All right. So, Task Manager. This is what we really get with Task Manager. And when we're doing that, we're really looking at processes that are running and the performance. Those are the two main things that we're doing with Task Manager. Registry, let's look at registry for a moment. Pull up reg edit. This is really the only way to, I didn't type it right. This is the only real way to edit the registry. Make sure I'm sharing that screen. Share screen, registry. Okay, so the registry is basically a long list broken down, or a long directory that make up all the different settings for your computer. So I can really mess up my computer by messing with this registry directly. It could have options about how the login screen works, if we can hide a user so that nobody can see that that user's available. So really getting down to the very minutia settings of Windows. Again, Task Manager lets me see what processes are running and also the performance. Event Viewer is really a log going back to everything that's happened on my computer. It could be errors, it could be saying that the computer just powered up and then it powered down. So registry is settings, Task Manager is performance log in real time. So we're really not going to see any past information. We're just seeing what's going on at that moment, whereas Event Viewer is going back in time, a log of things that have happened in the past. I think that was the 3 different chat, or let me go back to that chat. Sorry, Robin, I think I muted you. I will unmute you.
I could stay muted, it's all right.
It's okay. I was just trying to figure out where all that noise was coming from, and it wasn't you, but it was on chat. I just want to make sure I got to all Kayla. So she said Event Viewer, Task Manager, Registry. Does that make sense, Kayla? The 3 different kinds? They just all have 3 different purposes, 3 different places. Great. Awesome. We will not beat that dead horse anymore. Anybody else last week? Questions about Windows? I think really the key that we're trying to get through to that is just being able to be more familiar with the system, be able to move around it a little bit more efficiently. That was really the goal of the last module. And some of that's going to come into play right here when we start talking about data networks, because I mentioned last week that there are a few tools that are really only available by the command line. So if nothing else from last week, let's go ahead and get on to this week's. Okay. So we're really going to be talking a lot about IP addresses this week. This is the address that your computer gets from the router or from your ISP and allows you to communicate with other devices on the network. So why is it important? I guess it's not super important that everybody has an understanding of how IP addresses work. However, it really is the building block of how the World Wide Web is working and how we're able to communicate with others. So in a way, you could say it's only important for the postman to know how to deliver your mail to your address, but keep in mind how important that is to the entire way our physical world is set up by your mailing address. So this is really your virtual address on the web that can be really compared to each other as far as importance on that level. So when we talk about IP addresses, we're talking about TCP/IP addresses. This is just an acronym for Transmission Control Protocol, Internet Protocol. So Internet Protocol, IP address, pretty simple. We have two different versions of IP address scheme. The first one that we use today is called version 4. Version 4, if you've seen an IP address, is the one that you're used to. There is, however, an IP version 6 that we haven't really started dealing with yet. The reason why we're moving from this version 4, which has been in use since the very beginning of the internet, to the version 6 that we all keep pushing back and saying that we're going to get to it eventually, is because of the amount of addresses that are available. So with IP address version 4, every device that's out there that needs an address can pretty much get one, but we're running out of space. Right now, TCP, or IP version 4, can handle about 4.3 billion addresses. IP version 6 can actually do quite a few more. It can do 2 to the power of 128. So I have this written out. Let's see how bad I can butcher it. That's 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 374 quadrillion, 607 trillion, 431 billion, 768 million, 211,000, and 456 addresses. So that's the difference between IP version 4 and IP version 6 as far as how many addresses we have for every device on the internet to use. This is probably good that we're going to be moving forward soon. Maybe you've heard about the Internet of Things. With the Internet of Things, we start talking about things like refrigerators needing IP addresses on a network, smoke alarms, things like that. So we have this whole new class of devices besides smartphones, laptops, and desktops, or maybe just your routers, that might be looking for a public IP address. That's an address that's addressable across the whole internet. So it's very good timing that right when the Internet of Things is coming, that we are really in a pretty set position to move over to IP version 6. The negatives about IPv6 is that it's a little more difficult to notate. For example, let's pull up real fast what an actual IP address looks like. And I have to share the screen, 1 second. Okay, so what we're looking at here is a private IP address and one that's often associated with your router. So this is very likely the router IP address in your home network. We might change it up a little bit. It could be 0.1. Maybe your actual computer address on the network is something like 192.168.0.100. Basically, we're dealing with 4 octets of data. So each one of these bytes or octet makes up the IP address. To compare, instead of having 4 bytes of data in an IP address, IPv4 address, with IPv6, we do have 16 octets of information. So it's going to be notated a little bit differently, but just the actual way that it's written is going to be 4 times as long of an address. They do some things that shorthand. So if there's zeros, you can leave it out and do a double colon. Anyways, that's about as much as I care to share about IP version 6, but you might run into IPv4 when we're looking at things, and I just want you to have an idea about what's the difference between the two of them. So one's something we're not using quite yet.
And just to make a little interjection, this is very similar to the 10-digit versus 13-digit ISBN, except that they're not quite as well managed. So you can't get the 10-digit ISBN from the 13. Like you can't get the you can get the 10-digit ISBN from the 13, but you can't get an equivalent IP on IP4 and 6. They are completely separate, but it's the same general idea. More books are being written than were available ISBN numbers at 10. So just another way of looking at the IPv4.
No longer will keep up with what we have. So, and you know, some of the first people who created the standards for IP address never imagined something like Internet of Things, where all these devices would come on and start sucking up those addresses. Okay, so we've talked about public IP addresses and private IP addresses throughout some of the quizzes, and I just want to touch on it one more time. So public IP addresses are the addresses that your ISP gives you to your modem at your house. And that's the address, also, like say the address of a web server would have a public IP address. Those are the addresses that are routable out over the internet. Now we also talk about private IP addresses quite a bit. And those are the addresses that are not available outside of your local area network unless we do something called like NAT translating or port forwarding. Those are things that allow us to have a device that sits behind a router accessible outside to the World Wide Web. A couple examples of private IP address is what I just wrote a moment ago. So 192.168, and then it doesn't really matter what these numbers are because anything up to, 1 or 0 through 254 are acceptable numbers where X is. The other one is 10.0 .x. So these two addresses will never be addresses on the World Wide Web. They're only available for your local area network. So this is the type of addresses that we would expect to see on our printer or our local device. And we're going to take a look at how we can see those here in just a moment. Let's see. Last thing I want to mention, there's one other kind of address that's really not public or private, and you might run into it when you run into problems. And it's a 169.254 address. Again, the two following octets don't really matter. What this address allows is for devices that are on the same LAN that do not have a router giving out IP addresses. So these devices have not been given a private IP address. They self-assign themselves this address. And one device on the network might have 1.2, it's given itself that. And the next device might be 169.254.1.3. So they're on the same network, except for one is a .2, one's a .3. This address allows them to communicate with each other without having to have a router that's functional. However, you cannot get to the World Wide Web with that type of address. It does not allow you to go out through the router. Well, you don't have a router, so you're not going to be able to get to the World Wide Web. So what that means is if we were to look to find out what your device's IP address, and it says 169, we know we have problems right away, because that means your device basically does not have an IP address, and that's not going to work to get online. We talk about another type of address, and I just want you to be familiar with it before we move forward, and that's called the MAC address, also known as the physical address. I can't type. Physical address. This address is tied to your actual device. So your computer, or to be more specific, your network interface controller, your NIC, is given this physical address, this MAC address, when it's built. So this will actually be printed on the circuitry usually. So this is just like an address that nobody else can have. Every device out there in the whole wide world has its own physical address. We don't really use it so much for networking, but you will see it listed right along the IP address. So it's important that you know what that is, just so that if somebody asks you what's your IP address, you don't end up giving them the physical address. This MAC address takes a little bit different form. Instead of having the 4 octets, what we have instead is something that looks like this. That's a colon. Or instead, imagine it with dashes. So that's the setup of a MAC address, just so you're familiar with that term when it comes up later. A couple other things when we talk about addresses is you might hear someone talk about a static IP. Your ISP or internet service provider might even offer you a static IP address for your network. It's really not something we need a whole lot because a DHCP or a dynamic ranged IP address, one that changes over time, pretty much allows us to do the same things. But if I had, say, for example, a printer on our local area network, I don't want that device ever to be lost. I don't want the address to be changing. I want computers to always be able to find that printer. So when I set that printer up out of the box, I am going to tell it manually set this IP address on the network. And we'll look at that a little bit later when we talk about adding a network printer in the next 25, 30 minutes. So DHCP is when we give out addresses, usually from the router, or it could be from your ISP, saying this is the address that you need to connect through. Or we'd be given a static IP. And again, that could be an address we set locally on a device, or it could be from our ISP for our router. Last part of addressing and communicating over the network. We've heard of DNS servers. I'm sure the term has come up to you before. DNS servers act as, would be the equivalent of the phone book for the internet. Computers understand these IP addresses, but they don't understand things like google.com. That doesn't make any sense. So what a DNS server, and these will sit across the country, and it will tell, when I say google.com, what I mean is this IP address here. A lot of times you'll find that you have a DNS problem, but you can still get online. And there's some network tools we'll use later that shows how you can look to see if you have a DNS problem, and that's the reason you can't connect online, or if the internet's just down in general and you have no connectivity at all. So those are the different parts of what it takes to connect to the internet. Super simplified, I realize. So let's move on quickly and talk a little bit about network hardware. So we know the different parts of getting online are your IP address. We have DHCP servers that give out the address. We have DNS servers that change names that we can remember with the address, that the physical or the actual location of where to find it on the network. So we also have some network equipment, that the hardware that it takes to get online itself. When we, actually I'm going to pull up a diagram real fast. I think that'll be the most handy thing to do. Let's see if this one's a good one. Yep, this one's fairly decent. Share the screen again. Okay, so this is a network diagram. What we can see here, at some point we have the internet, and that's in the top part, top section. Then from there, we start having our own equipment. As you can see from the left and to the right and down, it moves to the router. So the router would be the device that, the first device on our network. It can be combined with the modem at times. The modem might be part of the actual internet as far as this diagram goes, because that could be owned by the ISP, and some of the functions kind of vary between devices. The main thing is we look for a modem to get us internet working for our building. It then goes to the router. Sometimes this firewall that's listed below the router is included with the router. So the router is the part, the DHCP server, that gives out IP addresses. The firewall does things like opens up ports so that computers are available outside of the network, or a web page might be available, or a printer might be available out to the web or out online. Then we have a switch listed underneath a firewall here on the left side. A switch just breaks up a connection so that multiple devices, in this example, phones, all connect to the switch. There is an older device that was similar to a switch called a hub. The difference between a switch and a hub is that a switch is a smart device that knows to send packets only to the devices that it's trying to reach because of its address. A packet is sent, and in the header of the packet, it has the destination IP address. And so rather than sending every packet across every port like a hub did, a switch is smart enough to just send out in certain places. That is important because it keeps down on packets crashing. We can't have two packets try to use the same wires at the same time, because that equals a crash and means the data has to be resent, which slows everything down. So we pretty much are looking at routers, switches, and then the network interface card on your computer. And that could be a wireless card or the one that the Ethernet cable plugs into. There's one other part that's not on this diagram, and that's what we call the access point, or the wireless access point. And as you can imagine, that is the part that allows us to get on the Wi-Fi. Again, that could be included with the router and firewall under all one device, but usually what we try to do these days is to keep access points separate. That allows us to have access points cover an entire building, front, back, outside. Also, another part of that is the wireless access point controller, or the wireless controller. That could be part of the actual access point. What it is the brains of the wireless network. It tells us what SSIDs or what names of networks are available. It tells us the security that we can have, and it might even act as a DHCP server saying that wireless devices all get this IP address that's completely separate from the IP address range for the rest of the equipment. So that is pretty much all of our physical hardware that we use in a data network. This becomes important when we start talking about troubleshooting that equipment. All right, we can move forward, stopping that share. Now we're going to talk about a little bit of troubleshooting. What time is it? 2:22, perfect. Okay. I'm going to open the control panel. Better share my screen. So to open the control panel, what I'm doing right now is opening the run box like we did last week and typing control and hitting enter. There's other ways to get to the control panel. You could just open the start menu and hopefully control panel is there. Again, from last week, I just know that if I open a run box, type control and hit enter, I'm getting the control panel, and it doesn't matter what other settings have been made to the start menu. What I'm going to be looking for then is network and sharing center. Let me share this. There's one thing I'd rather Zoom did is change the way shared windows, because it takes a second. Okay, so I hit control panel. That takes me to here. I could be in category view, which is fine. View network status. And then I'm going to change adapter settings to actually look at the different adapters. So these are the different hardware connections I have available for networks. Some of them are kind of virtual, the bottom ones. But other than that, we have a Bluetooth connection, which is a type of network connectivity. We call that a personal area network with Bluetooth. Then we have our local area connection and our wireless network. As you can see, I am connected to NECLS Secure, and that 2 just means basically that's the second connection I've made to NECLS Secure. I probably forgot one at one point and added that one. So you might see Library 2, Library 3, Library 4. Basically, all that means is that's the 4th iteration of that network that you've connected to. Really don't pay too much attention to that number that comes after. But you can see I'm connected to NECLS Secure Network. Local area connection, you'll see, has unidentified network. This is one of the things you will see when your network isn't working. And if we go down here to our network, I'm not sharing the screen. Let me share a different screen. Share my whole desktop. There we go. Okay. So another place to see where network connectivity is down in the notification area. If you called and said, I could not connect to the internet, we'd probably try to figure out what is the notifications you're either getting in this network connections area or down here in the notification area. They should be telling us similar things. So we can see that I have an unidentified network for LAN, and that's the same thing over here, local area network. We can expect two different main messages if we're not connecting. One of them is this identified network. The other one I'm going to create right now. So you could also see network cable unplugged. Sometimes you look at your computer and you look, and there is definitely a network cable unplugged, and you plug it in and plug it back in, and it still doesn't work. Be aware that if your computer at some point plugs into, say, a switch in a data closet somewhere, and if that switch has no power to it, then it's going to show up that your computer has a network cable unplugged. So that can be a little confusing at times. Anyways, so a network cable unplugged error that I'm just going to recreate again one more time. That could mean that there's something not plugged into your Ethernet jack on your computer, but also it could mean that whatever you're plugged to on the way other end of that Ethernet cable, it might just not have any power, or it might be unplugged from something altogether. So that's one of the errors. But you can see here, that's not the one we're dealing with right now. We have unidentified network. So how am I going to troubleshoot this? The first thing I'm going to do is I'm going to bring up a command prompt. That was the command line interface that we looked at last week. And we're going to try to get a little bit of information, a little bit more than we have right now. So let me open up command line, CMD, enter. And I'm going to start with our first command line tool, which is ipconfig. That's IPCONFIG. Again, some of this is important, not so much because I expect you to ever do this, but if you had network connectivity problems and we were trying to get you back online over the phone, it would just be really nice that you had actually seen ipconfig before or had an idea of what I was talking about when I said ipconfig. Anyways, let's go ahead and hit enter. Here we're going to have information about all of these different network adapters. So this is just a different view of it. The first one is the wireless LAN adapter network connection 2. Actually, there's one above that. And we can see that that one looks pretty normal. It has that IPv4 address, that version 4 address that we would expect. It's a local area one. It has a subnet mask. The mask is what allows us to break a network in different parts just to get more usage out of it. And then it has a default and gateway. Okay, but that's not the one that we have problems with. The problem is this Ethernet adapter local area connection. So it has an IP address, and it has a subnet mask, and it has a default gateway. The first thing I notice is that this subnet mask does not look like what I see above it. I would expect the subnet mask above because that's what we see in small networks. So there's definitely a problem with the IP address on this Ethernet adapter. And that could be caused from a couple of different things. If I was getting no address here and I said unidentified network, then that would be a really good sign that the router is not giving out IP addresses. But I do have an IP address here. So that means there's something goofy going on with this particular computer. And I know that's because I actually did this on purpose to try to show that error message. Let's go ahead and take a look at where we could change that address. So I'm going to right-click the local area connection and choose Properties. Again, some of this is just so that you've seen it before, so that if it ever came up in the future and somebody had to walk you through it to say, go to Network Adapters, right-click it, highlight Internet Protocol version 4, because that's what we're interested in right now. And we're going to choose Properties. And here you can see that IP address. So somebody, namely me this time, has set a static IP address for this computer. And that address is not in the correct range. I am pointing to a gateway that does not exist. So what I'd want to do is switch it to the actual gateway address, which I know is 192.168.1.1 at this particular network. I know that a subnet mask should be this. And I know that I need to have an IP address in this range of the gateway. So this 1.1 is not going to work because that's used by the gateway. But pretty much anything between 2 and 254, as long as that address isn't in use already on the network, should work just fine. So 230, I'm picking out. We could set DNS servers. You will see this common 8, 8, 8, 8, 8, 8, 4, 4. These are what are known as Google DNS servers. So I can use these servers to change names from IP addresses to actual web pages. So let's go ahead and hit OK. What should happen right here is I have this in the correct range, and we should see this change to allowing a network. It's identifying right now. Give it a moment, and that will secure to. I didn't necessarily have to create a static IP address right there, but I would want to do that if my router wasn't giving out addresses anymore. So we see that pretty common, especially with routers that have been running and running and running for a long time, and possibly if they're kind of cruddy routers to begin with. We're looking at CenturyLink. What happens is that their routers stop giving out IP addresses to devices that connect on the network. And so what you'll see is, well, my computer I always use, it has an IP address and it's connected to the network. And one of the patrons who comes in every day, their device is connected and it has no problem. But this lady who came in who's never been here before, she tried to connect and she couldn't get, it wouldn't pull an IP address. That is because the router is not giving out IP addresses anymore. So a workaround is to set that IP address manually. And if that's just enough so that we can then remote in from our office and help you out and get in your router, that's great. But again, I could just go ahead, since everything is working correctly, I can switch that to obtain an IP address automatically, obtain DNS server's address automatically. And that's going to work just as well because I don't have any actual network hardware problems right now. As we'll see, yep, it just connected. Okay, so that is how we use ipconfig. It is to look to see, one more time, what addresses I have on my device right now. And it lets me look at wireless and the LAN at the same time. Now you can see I have two addresses. They're pointed to the same default gateway. That's my router. And they both have addresses assigned to them within the range that we use on this network. So in a nutshell, that is how you use ipconfig. And it's mostly used, again, just to see if we have an IP address. I mentioned that 169.254.x, whatever it is, address earlier. If I did an ipconfig and I saw 169.254, then I would know another sign that my router is not giving out IP addresses, because that is within the range that Windows assigns itself when there's nothing else giving out addresses there. Okay? So that's hardware, and we're still on troubleshooting. We talked about static IP, so now we're going to talk about the next command line tool that we can use for network connectivity. If we lose anybody here, I know this stuff is kind of a little out there. Okay. All right, let's talk about the next network tool. We get to it the same way. We open up a command prompt or a run box and we type CMD. So now we're going to look at a tool called Ping. That's P-I-N-G. What Ping allows us to do is to see if an IP address is accessible. That's all it does. It's a super basic tool. So what we're going to do for starters is say, I want to see if I can get to a website right now. We're just looking for basic connectivity. So I'm going to ping google.com. And on Windows, it's going to do it 4 times. And what we see from this is that it sent 4 packets and all 4 of them were received. So it's packet sent 4, received 4, lost 0. So we know that Google's available. We could do that with local network equipment too. So let's say I couldn't print. I'm going to ping the IP address, the local private IP address of our copier, and see, even though I can't print to it, can I just ping it? Can I see if it's just online? So our address for that happens to be .12 for the IP address, I do believe. So we're going to try and connect it. So what did I just learn from doing that ping on our copier? I couldn't print to the copier, so I'm knowing something's wrong. And I'm wondering, is it the network connectivity? That ping just satisfied to me that that copier is indeed online on our network. So I must be looking for some other reason. Maybe it's a driver, maybe the printer has a jam. So I know it's not a network problem. I need to shift my focus somewhere else. So that's why we use ping the most. It also allows me to figure out if we have a DNS server problem. So if I can't get to google.com, it might be that I just have no internet connectivity at all. But it also could mean that the DNS servers that I use that change google.com into its IP address could just be down. So first I'd have to know, what is the IP address of some sort of web server out there? You could look that up. Another way of looking is when I ping it, I'm going to see the actual address. Let's look again. So that 172.217.4.110, that is the actual IP address of at least one of the Google servers. So if I wanted to make sure I didn't have a DNS problem, I might want to go ahead and ping a public IP address, 172 in this case, .217.4.110. I'm going to ping that. And yes, I can get packets and there's no loss. So if I could not ping google.com, but I can ping 172.217.4.110, that means I've got a DNS server problem. So that means I probably need to change which DNS servers I'm pointing to. If it really just depends on whose DNS servers I'm using at that time. It could be Google. It could be the DNS servers that my internet service provider give me. A lot of times in the library, it's open DNS servers. That's a whole other rabbit hole to talk about. Open DNS servers are what we use to get the create a pornography filter for our patron computers and basically any computer on the network. So those addresses, instead of 8.8.8.8, are 208.67. Oh, now I'm on the spot and I can't remember. I've only done it a million times. Anyways, I'm on the spot right now. I'm not going to remember it. Whole other DNS server address. That's another reason why we will use ping. So we have 2 command line tools so far, ipconfig and ping, and there's one more we're going to talk about, and I'm going to give you an example of when we might use it. This one is called trace route. It's simplified by just saying TRACERT, and just like ping, we put a target address. And let's look to see what happens when we do a trace route. So what we're seeing here is the packet path that goes from my computer all the way over to Google servers. And we get to see every hop that it makes. So from our local network, it then goes to the staticsunflower.com. That would be our ISP. Some of you might remember that before our local service provider, which is called WOW, used to be called Knology, and before that it was called Sunflower. So we can see it goes to a couple of old servers here in Lawrence, probably from Sunflower. Then it hits another one from Sunflower. Then we get Knology, which is probably down in Florida or who knows, wherever Knology still has servers running. Then we kind of bounce out. We're not sure where these places are. And finally, we end up at the Google. So every time I make any kind of request, just know that the packets are going through this whole path. So we might use trace route when we're trying to determine why certain sites aren't available or why certain sites are really slow. Oh, we got an Amber Alert, everybody. Everything's loud, loud, loud. Okay, so trace route. I'm trying to determine if I have a problem with my internet. I think Connie might be out there, I'm not sure, over in Richmond, Kansas. So what we've seen there a little bit is that they have issues connecting to certain servers, or maybe Koha, or it's just slow in general. So we might be using ping and we might use trace route to determine where there might be a breakdown. If I did that trace route a moment ago and I saw about halfway through that there was a server that was unreachable, then I would kind of know that that would be the problem with my connection. And at that point, I might need to call my ISP, but at least I have this information and I can say, hey, every time I try to go here at this server address, 75.76.35.10, it fails and won't go there. So at least then you know it's the ISP. Again, with the ping, the same idea is, let me say I ping the staff, the Koha, which is staff.expresslibrary.org. Let's say I ping that. And every time I ping it, let's say I lose 2 packets. Well, that would be a pretty good sign that either Koha is having issues or I'm having issues with my connection. I shouldn't be dropping packets. If I did say I lose half of my packets going to staff.expresslibrary.org, then I'd probably want to do another ping to something like yahoo.com and see if I missed the same packets then. If I'm dropping packets no matter where I go, then it's definitely an ISP problem. So again, if we're dropping packets, you might have a great speed connectivity, but if you're dropping packets all the time, your connection is going to be super, super slow. Those are the 3 command line tools. You might not ever really need to use them, but really, as far as troubleshooting networks go, they can be super handy. We might, if you had connectivity problems with Koha, ask for you to do trace routes and to save the logs. That way we could create a baseline and know when it works normal and when it doesn't. This is all about collecting information so that we can find a resolution to a problem. I think we'll move on from those 3. You know what I wanted to do and didn't do yet is talk about this week's objectives. I kind of jumped ahead of myself. So we'll get back to power cycling network connectivity in just one moment. But this week's objectives are: the learner will know what broadband speeds they should be expecting and be able to check what their current throughput is. This kind of ties into the first lesson here, broadband performance. All I ask is for you to look through that information so that you can see a few different tips and hints about dealing with your ISP. A lot of it is about dealing with problems that you have with your ISP. So look that through, but it's really not on the quiz. One thing we will talk about in that section that's probably the most important as far as knowing what your broadband speeds are and what you should expect. So the one part of that is to know what you're paying for, and that should be on your bill. And if it's not, you should be able to call your internet provider and say, what is the download speed I'm paying for? What is the upload speed? So then I have that information. I'm going to go to speedof.me. I use this site because it doesn't require any Adobe Flash. That means it works on mobile. I don't need to have an app. It'll work if I go to the Safari browser or Chrome browser on my phone. It'll work just the same way as if I go to my desktop. I'm going to go to speedof.me and I'm going to click the Start Test button. And this is what it's going to show me what my current internet speed is. And as you can see here, I'm looking at about 10 megs from my machine. Now it's dropping. That could be a multiple of reasons. We do have some settings for our local network that tries to limit how much data each device on our network can pull. That way I'm not sitting over here using all the network while Greg and Laura and everybody else suffers. So that's part of the reason why I'm seeing the speeds that I am. It also could be because I'm running a speed test while hosting a Zoom session. So I am uploading video software and downloading at the same time. So this is what I'm trying to get at, is that although this is a good tool, this isn't going to be necessarily accurate unless I know there's really no other activity going on. And really, if you need to find out what your speed is that you're getting, you're really going to want to hook up a laptop or something directly to the modem and bypass all other network equipment on your network, and maybe even unplug the data network from that modem so it's just your laptop, and then you run the speed and you really get an idea of what you're seeing. So before you start calling the internet service provider, you might need to actually connect directly to their equipment and run some speed tests and see what you're getting. Again, that first lesson talks a lot about different processes you can take, making logs if you have poor performance, just some steps in dealing with your ISP. Next, objective. Given the Windows operating system, which I am on today, the learner will be able to use the following CLI networking tools, and those are the ones we just covered: ipconfig, ping, and trace route. There's not actually an assignment or a quiz about those. However, the assignment we have for this week will ask that you use those basically to find the information we need. Given the Windows operating system, the learner will be able to install a network printer. This falls under this assignment here. I'm not going to get into how to do it because what I already created is a walkthrough on how to do this on a Windows 7 machine. So you should be able to go follow along with these steps. I have pictures, and I'm just asking that you go through and you install a network printer on a computer in your library. You can do this on a deep freeze computer so that as soon as you make your changes, all you need to do is reboot and it'll be back to the way that your tech person set it up. If you do not have the credentials to add a network printer on your network, then you might ask to see if somebody can give you that permission temporarily. If you still can't get anywhere with that, then I just ask, go through the assignment. Just go through the screenshots so that you get an idea of what the process is like. Back to objectives. The learner will demonstrate understanding of a local data network by creating a network topology map of their library. Rather than you creating your own network diagram, which I realized would probably take a little too long, instead we have an assignment where you download a Word document and you then follow along the steps to get the information you need to fill out that network diagram. You just click on it so you can get an idea. So what we have is a Word document that you will download and fill out. You'll save and turn it in. Open it with Word. So there's going to be 5 different areas. I don't know why I didn't remember my numbers. There should be numbers in the middle of these circles. I'm wondering if something's just a little screwy with my version. There we go. So, step 1, you find what your public IP address is. This is your address that you have on the internet. Then you find out what the address is for your router, and that's subnet mask. You're going to find out what IP address you have on a workstation computer and the address that you have on a wireless device. Finally, you're going to find out the address of a network printer. So that might seem pretty daunting, but what I have is a walkthrough on what you need to find that information. So, for example, for step 1, to determine your public IP address, the address that you have that basically your modem has on the ISP's network, you can simply Google my IP and the results will tell you what your public IP address is. Step 2, you're going to use ipconfig to find out what that address is, just like I showed you a little bit ago. Same thing with the workstation IP. The ipconfig tool will tell you what the gateway address is for part 2 and what your IP address is. Step 4, we're just going to do it on a device that's connected with wireless. And then finally, looking at those instructions for installing a network printer, and I think I said it's in step 3, you'll be able to see what the printer's IP address is. So that's this week in a nutshell before you're all done. Make sure there's nothing else. Complete the network diagram. Oh yes, there's one. I don't even want to call it a quiz, but what we're asking you to do, and this will take us back to where we left off on the other part, is you're going to put in order the correct steps in power cycling your network equipment. So we have these drag and drop boxes where I'm just going to say what comes first. I plug in the router, no, I unplug the modem, and we'll cover this right now, but just not in that so many terms. Back to where I left off my outline of the day. So we just talked about IP config, ping, and trace route, and now we're going to talk about power cycling network equipment. We've talked about power cycling in the past, so hopefully this isn't a foreign concept. When somebody says power cycle, what we mean is to pull the power from the device, leave it for 15 to 30 seconds so the capacitors can all drain of the power. Then we'll plug it back in so that the device can do a completely fresh reboot. So with network equipment, what we want to do is pretty much unplug the modem and the router from power. Then, once we know that everything is waited 30 seconds or so, we're going to plug the first device that comes into the network. And the first device that comes into our network at most of these places is the modem. So we're just going to follow the path of data that data flows through your local area net connection. First device, again, is the modem. So we've already got the modem and router unplugged from power. I'm going to go ahead and now plug the modem in, and I'm going to wait. And I'm going to see the lights on the modem fluctuate and flash. But eventually, maybe about under a minute, all the lights should kind of come to a stasis, a way that they act when everything is working normally. And that can really change from modem to modem. A lot of times, what we do is take a picture of how a network looks when it's working and leave that picture right next to the network so that we can compare it side by side and say, okay, this is what a modem looks like when it's ready to go. So I plug the modem in. The router is still unplugged from its power. Everything on the modem has kind of come to a normal stasis. I'm then going to plug the power back into the router and wait. Again, it could be about another minute or so before that router comes to some sort of normalcy. At that point, if a power cycle was going to fix the problems, you should be pretty much now fixed. This happened to me as recently as this morning. So Baldwin called and said that one of their networks, the one that staff used, wasn't working. They said that they had done a few different troubleshooting steps, but still nothing was working. What can we do to get them back up and running? So luckily we have some information here about their network. Also, luckily I've been here for over 5 years and installed that network myself. So I can go off the top of my head and know that the staff modem is on the left-hand side in the data closet. And so I asked them, how do the lights look on that? And they said, yes, it's lit up. And they said, well, there's a reset button on the router, and we tried to press that and it still didn't work. Let me just take a moment to caution you about reset buttons. That is usually the last-ditch effort we have to fix everything. The reason being, if I clear out my router, then the IP address it starts using out of the box by factory default might not be the same local area network addresses that I use for my printers, if I have any other static IP addresses set. So if I do a hard reset, it very well could break things maybe even worse than I did already. So really, we're talking about power cycling as the #1 thing that we want frontline staff to be able to do. And so that means you also need to know what the power cable is. This came up earlier today as well. We're saying, which black cable do you mean? And I have to explain, not the Ethernet cables, so not the cables that look like big phone cables. I'm looking for a power cable. And you might be surprised, because sometimes I am, how often people get confused about what is the power cable on the device. So I just ask that you don't take it for granted that everybody knows what the power cable is. If we have to step back a second, I'll say, follow the cable and see which one is plugged into the power outlet. Usually on a device, though, you should be able to tell with a little bit of experience which cables are the Ethernet cables. Again, those are the ones, you guys can see me right now, the ones with the little clips. Looks like a big phone cable for when you used to have a landline phone. These are your Ethernet cables. If I'm talking about power cycling, we don't need to touch these. We can leave these right where they go. It happened a little too often probably where people have gotten a little unplugging happy and pulling everything apart, and they're not quite sure where it goes after that. So really, just the power cable, know which one that is, know what the power cable, look at stuff when you're not in a panic so that you're familiar with it enough that when things are bad, when you've got 5 patrons in the library and you just need to restore internet, so you have an idea of how that stuff works. Follow along with your diagram that you will create and unplug everything that way. I did mention switches before. Probably a good time to mention. Switches usually don't need to be power cycled. After an outage, also, it's not usually necessary to reboot a computer. Although if you find that certain devices are coming back up after you did a power cycle and others aren't, probably a good time to power cycle that computer or reboot that computer and make sure it works. Again, though, we're really looking at routers and modems when we talk about power cycling, and then also probably the wireless access points. Those switches pretty much can just keep running and running and running. As soon as they get data packets going back through them, they're going to start passing them back through again. So a little bit more robust, maybe just because their job's a little bit more simple. That's what I have for power cycling. We have some other tools when we talk about data network troubleshooting. There is software that we can use to analyze the traffic going through. And Neckles purchased this kind of expensive little tool last year. This is made by the company Fluke. It's a link tester, basically, Fluke Networks. It's called a link runner. So this is something that we could bring out to a library. And what we're able to do is actually check your data cables in your library. So it might be that if we have one particular device that isn't working well, it could be that it's just on a bad cable. So something like this that we have access to would be able to help us know if there's an actual physical problem with that cable. The other thing that this little guy can do that we didn't have the ability to do for years and years and years is that it can be a tone generator. So I can plug a cable into this, and then this little device will start making a sound that goes out over the copper wires. I then have this little tone generator, and I'm able to walk around the library and probably more like in a data closet, and if it finds the source of that signal, then I can know where that cable goes. So just some other tools that we have that you probably don't have at your library because they are fairly expensive, that allows us to find cables and to test them inside your library, because it's not always the ISP's problem. Sometimes it's ours. Especially with these older buildings, we can run into a lot of problems. And so just something to be aware of, that we have that available to us. I've got one more thing in these last couple minutes. I want to talk about network printer options, just how to get to it, because we're going to have that in that assignment. The easiest way is to go to Start Menu. Oh, I got to share my screen again. Just to get to printer options, the easiest thing to do, it's usually right here. If you can't find it, go to Control. That's the open the run box, type Control, and go to Printers. Printers and devices, devices and printers. Here we go. So I have a printer here, and I want to know what the IP address it is. If it's already installed, I can go to Printer Properties, and I can click on Ports, and I can open this up, and I can see it's that address that I looked at before. The last point I want to hit home is network printers almost always have a web page that's embedded on it that allows me to communicate with that printer. And it sits at the address that that printer lives on. So I can open a browser, and this goes back to just troubleshooting the connection. And I could type in that address just like I would any other URL, .1, .12, And this allows me to see the page. There's usually some sort of login. But this allows me to get to some, I don't have the right address. This allows me to see some more options for the printer, and it's just another troubleshooting step. So I just wanted to make sure that you are aware, if you've never heard it before, that every network printer out there, you can go to its built-in web page if you know its IP address. So that can be helpful when troubleshooting things like network printers and seeing if a job didn't go through. Anytime you don't have access to the actual copier itself, for whatever reason, that can be helpful. That pretty much finishes us up. I did want to make another point about the broadband performance part. That's going to be specifically useful to you if you're the person that makes decisions about getting upgrades on your broadband performance as far as the speeds that you're going to get. But if you don't have anything to do with that at work, keep in mind this might be helpful as well when you're dealing with your ISP at home. So there might be some nuggets of information in there that are helpful when you're dealing with outages at home. That is everything I have to say. I've been talking for an hour. Oh my God. Does anybody have anything they want to mention before we all get out of here? I will mention that after this week's module, there is that same assessment. If you want to take that, that would be great sometime next week so that we can see if there was any change. As I've mentioned to the people we've met with in the past, the competency survey, the assessment does not go hand in hand directly with everything we covered in the tech labs, but there are certain things that kind of have a carryover. But we'd love to see how your mind has changed for that self-assessment. And then please also look at this NECLS Tech Lab survey and fill out any information you can give us. This really was the 0.1 alpha version, and you were the guinea pigs for Tech Labs, and we do appreciate it. And I've said it before, and I'll say it again. Thank you so much. And any kind of input you can have is really just going to help other library staff people out there, so that we can have a better product for them. We had a lot of people, especially in the last year, say they want training, but they weren't sure what kind. So this is just a step that we took to try to get us closer to that goal. Okay, I don't see any messages popping up in chat.
Other than a few thanks from Todd and Jack and Travis and Kayla.
But I've said it before too, if the only benefit you got out of this class is that you feel more comfortable